So hello, everybody. My name is Anne Currie, and I have been in tech industry doing various things for nearly 25 years. And the latest thing that I've been doing, the most recent thing, and probably one of the most interesting things I've ever done, is be part of a project called Microscaling, where we were looking into what impact containers might have on data center hosting over the next year, 5 years, 10 years, however long these things always take to roll out. And I think there is some very interesting stuff coming. There's undoubtedly some very interesting stuff coming. And there are some interesting use cases for containers that are beyond what you normally hear. So I've got another tranche of folk coming in the back. Because, yeah, there's undoubtedly at the moment a bit of a battle going on for what will be running on the bare metal in data centers over the next decade. So the first thing I'm going to do is kind of teach, as we say in the UK, teach my grandmother to suck eggs, tell you something that you already know, which is step back, look at the contenders for running on bare metal in the data centers at the moment, and see what their strengths are and what their weaknesses are, and what that might imply, what that might mean about what happens and what happens next. So there we go. Let's step back and look at the traditional, the server, running directly, your applications directly on the server. So 15 years ago, this is what we were doing. This is all we were doing. This is what we're doing all the time. Even 10 years ago, I think most of us were mostly running our applications directly on servers within our data centers. And that was fine, because obviously the servers are the ultimate source of power. They are where all the action happens. Even now, even if you're running with a VM or with a container, you're still underlyingly running on a physical machine. As we say, even serverless still runs on servers. But the reason why we stopped, the reason why we started to back away from running everything on servers in the data centers was because they are somewhat inflexible. They have poor spin-up speeds, but most of all, they are quite poor for resource utilization, because what you tend to have is one application running on one server. And actually, that is almost guaranteed to be quite inefficient, because the application doesn't necessarily use everything that's all of the resources, the CPU, the bandwidth, the memory that are available on that server, but the server's still powered up. So you're still paying for it, you're paying for the space, you're paying for the cooling, but you're not actually getting full value out of it. You're not using it for useful work. So they had quite poor server density, server resource utilization. So then came along, around 10 years ago, the new contender, which was, their first competition at the time, which was the VM. So the VM addressed an awful lot of the weaknesses of physical servers. They were extremely flexible. As opposed to being inflexible, they were incredibly flexible. So with a VM, obviously you can run any guest operating system you want on any host operating system. They're very secure. The networking is very good. They are very mature technology. They do an absolutely amazing job. And the modern cloud would not be possible without VMs, because in the world of running physical servers in data centers, it's just too resource inefficient to make the modern cloud work at a cost-effective price. So fundamentally, VMs are utterly key to the modern cloud environment. But that doesn't mean that they are perfect. So they are still somewhat overweight, because generally speaking, you're running a whole guest operating system on top of a whole host operating system. So you get an awful lot of protection, an awful lot of wrapping, an awful lot of security, but you pay a heavy price for that in terms of how much of the resources on your server are going into just running the VM. They're also startup speeds vastly better than a physical server. So if you want to expand your capacity, we're using physical servers, that could be days, it could be weeks, it could be months. There's an awful lot of work that is required to bring that new resource online. With VMs, it's minutes. So fantastic. You think, well, it can't be better than that. But minutes is still a long time in computing. Minutes to bring up additional resource is still not real time. If you if you get a sudden peak in traffic and you have to wait minutes to bring in additional capacity, which is what autoscaling does for you, then that is not real time. You will still lose your customers while you wait those minutes for the new resource to become available. So autoscaling, it's not magic. I mean, it can feel like it's magic. It's certainly much better than anything we had previously, but it's really not magic. It's not real time. You still have to plan for your expected peaks in traffic in advance. Otherwise, you will fall over. You will have downtime. So it's great. So VMs were a huge step forward, but they were not completely revolutionary. And then we get the latest, the newest contender, which is containers. So containers genuinely take all of the benefits of VMs and then step them on even further. Doesn't mean they don't have downsides, but they are quite interesting technology from the perspective of resource utilization. So unlike a VM, they provide a degree of application isolation. So when you're running in a container, you wrap up your application and you run it as a container. Then the container engine can say, well, this application, you can do this, but you can't do this. You can have access to these resources on the machine, but you can't have access to these resources. And that all happens within the kernel. So it's fast, it's lightweight, it's low overhead. So it's very, very lightweight compared to a VM. And it's very quick compared to a VM. So you might be able to fire up a container in seconds or even sub-seconds, as opposed to minutes for VMs. So suddenly, you're getting something that is genuinely, as far as a human use case is concerned, real time. Because people will wait a couple of seconds for a change to happen, but they wouldn't wait a couple of minutes. So from a resource utilization perspective, containers are extremely interesting. Now, it doesn't mean they don't have their downsides. They're still quite unproven technology. They are not as secure as a VM at the moment. They probably never will be, because all of that heavyweight wrapping around a VM was actually provides an extraordinarily a high degree of security. And containers won't provide, I think probably will never be quite as secure as a VM could be. But the trade-off is that they require fewer resources to run, and they are much, much faster, which has a completely different spin on how you might run a data center, which is what we're going to be talking about today. So for me, the most interesting part of containers is the speed. That isn't generally what people consider to be the most interesting thing about containers. It isn't why containers have taken over the world and everybody's going container mad. They're doing that for other reasons, which I will talk about in a minute. But for me, the thing that's genuinely revolutionary, the thing that could really, really change everything we're doing about containers, is about the data center, is their instantiation speed. But how did we get here? Why are people so keen on containers? And was it ever instantiation speed that caused the huge interest that there currently is in containers? For that, I think we need to talk about the backstory a little bit. And there is no backstory on containers which is not primarily about Docker. Because we all know that containers were invented in 2012 by Docker, who invented it as an amazing packaging format so that we could package up applications and move them easily from place to place, put together all of the applications and all of the libraries and the dependencies of those applications, wrap them all up nicely together, and put very consistent APIs around them so that you can move them easily from place to place, from dev to test to production. And this happens to coincide with our interest in continuous delivery, continuous integration, and it works very well with continuous delivery and integration. So it just absolutely hit the zeitgeist. So we tend to think of containers as around the packaging format. That has been the use case for containers that have popularized them. And we shouldn't underplay that, because that's been incredibly important. But in fact, containers were not invented by Docker in 2012. They've actually been around for more like 10, 15 years. And they have been used heavily throughout that time by, and originally they were developed by companies like Google and Sun when they still existed. And Google still use them extensively today. Netflix now use them extensively too. And they use them in a large part to help with their resource utilization, so that they get to use their machines in the data centers far, far more efficiently than we do, not using containers. So to give you some kind of idea about the massive step up in resource utilization you get from using something like a container. So Google, I mean, obviously they play their cards. They play their cards very close to the chest. They don't necessarily tell us everything that they're doing. But the general belief, and I think this is probably true, seems to be that Google run at about 70% utilization in their data centers on their production systems. To compare that with what is the industry average for data center utilization, it's around 10 to 15%. So Google managed to run their data centers 4, 5, 6, even 6 times more efficiently than we do. And they do that because they wrap all of their applications up in containers, and they effectively tessellate them on their machines, so that they can, if they've got a big machine here, they can put an application there, and then there's a bit of space for another application there, and another one there, and another one. Oh, there's a little bit of space there for a high memory usage application. I'll put that in. So it's a bit like a game of Tetris. I don't know if anybody's seen. Kelsey Hightower from Google often demonstrates this as a Tetris game. You can really, really use your resource utilization extremely well if you've containerized your applications and then you've orchestrated them. So we'll get to that. So that's also utterly key to this. Now, why is this important? I mean, obviously it's important because it cuts your hosting bills, and that's why Google have done it. They just couldn't afford to not do it. It's the reason why Netflix have done this as well. So they're at about 50% resource utilization on AWS, and they couldn't afford to run their service if they were paying twice as much to AWS in order to do it. So they do it purely for money saving. But there are other reasons too. I don't know if any of you guys were in the second keynote this morning. The Amsterdam, Mike was talking about how we can do better at not burning through all the fossil fuels and generally destroying the world. Actually, he missed a trick on that, because for us here at this conference, the biggest change that we can make is to use energy in data centers more effectively, because that's something where we actually, each of us has quite a sway. You know, whether or not we put one more, I mean, it's a good thing, you should put solar panels on your roofs, but we can only have a tiny, tiny impact individually by doing that. But if we can convince our companies to host our applications more efficiently, we can have a really significant impact. And there are a small number of us in the industry who can really help with that. And we would make a huge difference. So at the moment, data centers worldwide use around 2% of the world's electricity, which is, and that's going up at a huge rate, because we are constantly expanding our data center capacity. So we're already using 2% of the world's electricity. To give you some context, that's kind of broadly like how much energy is being used by the entire aviation industry. But the aviation industry comes under a lot of pressure to do something about it. We don't. Probably most of us in this room, I didn't know how much energy we used running data centers really inefficiently. So the aviation industry are under a lot of public pressure, and they do a lot about it, and they are quite energy efficient. We are very energy inefficient. So we're using a lot of energy. We're massively increasing the amount of energy we're using, and we're using it very inefficiently. If we wanted to have a massive improvement tomorrow in the world's energy use, then we would all go away and start putting pressure on. I mean, let's bet that in 10 years' time, we're mostly going to be in the cloud, putting pressure on our cloud providers to move over to renewable electricity. So Google already have. They have a target of 100% renewable energy-powered data centers worldwide by the end of this year. As a result of Google making that declaration, AWS have gone up to say that they will attempt 50% energy efficiency, or renewable energy use within their data centers by the end of the year. But the biggest change that we could make, forget putting a solar panel on your roof. The biggest change that we could make is persuading AWS to go to 100% renewable. It wouldn't just improve the general use of fossil fuels worldwide. It would also establish a market, a strong market in a growing industry for renewable energy. If we can make that happen, then we will be in a vastly, vastly better position, and we could all do that. All we need to do is, if you are choosing a cloud provider, choose one, make one of your factors that you're considering whether or not it runs on renewable energy. So there's already Google who do, and there's Amazon who don't yet, but will do if we put pressure on them. So if you say to Amazon, well, I was going to use you, but I like Google's 100% renewable energy commitment, then that will put pressure on Amazon. Even if you don't do it, even if you still choose AWS, just tell them that you really thought about not, because they weren't as good as Google in this. Let's put pressure on them, let's make a difference. And that could make one hell of a difference. We're talking about the size of the entire aviation industry, and that's in the hands of us, techie folk, who are quite a small group to make this change. So we can really have much more of an impact by just effectively twisting Amazon's arms a little bit on this. Yes. So, but anyway, so how did they do it? How did they do it? Sorry, I've harangued you enough. But I was thinking when Mike was talking earlier that actually we were missing a trick. This is where we can really make the difference. How do they do it? Well, they do it with cunning orchestration. So that kind of tessellation, placing applications on machines to best use the resource that is available across the cluster, across your entire estate. It's called bin packing. So almost all of the orchestrators that are available in the market today, I think actually all of them, support bin packing. That's a really useful feature, and it's one you should be considering turning on if you move to orchestration. Fault tolerance. They use orchestrators to effectively make sure that there are a minimum number of any vital servers that you've got across your data center running at any one time. So you don't necessarily just always have to have two machines up and running, and one's not doing anything, and the other one is one's running your application, the other one is there ready for a hot backup. Using fault tolerance, they can be a little bit more clever and spread your applications around your entire data center a little bit more efficiently. So bin packing and fault tolerance are two of the key things that they do. The other thing they do is a little bit more intelligent scaling. And that is what I will be talking to you about a little bit about next. So yeah, we talked about the clever orchestrators, loads of good ones on the market. We currently use Kubernetes, but we've used ECS, we've used Mesos. They're all strong contenders. We quite like Kubernetes at the moment because it seems to be the one that there's the biggest community behind. So you get a lot of new functionality. It's quite powerful. And just to remind you, the win here, the goal that all data centers should be going for, this is what Google decided to do, this is what Netflix decided to do, higher server density and self-healing, fault tolerance, lower maintenance costs, all of which were really why containers were invented. So the next thing I want to talk to you about a little bit is the clever scaling that they're all up to. So I'll give you a worked example of how that kind of clever scaling might work. So imagine that you were a company, cutekittens.com, and your business model was that people came to your site and viewed incredibly cute kitten videos, and they could also upload their own really cute kitten videos. So and this is great, all going well, you've got people there, and they're watching the kitten videos, and they're uploading the kitten videos, absolutely fantastic. And then somebody, some fool, goes onto your website and uploads the cutest kitten video the world has ever seen, and it instantly goes viral. And you could never have it's just, somebody's kitten did something incredibly cute. Who could possibly have imagined that would have happened? And suddenly, the traffic to your website goes through the roof, absolutely stellar. You just were not expecting it. In the old world, your servers just fall over because what can you do? You can't auto-scale quickly enough to handle that peak of traffic. And all of your people who watch kitten videos are notoriously lacking in patience. And as soon as they can't see the cute kitten video, they just go away to your arch rival. Puppies are ours. And you've lost them, that's it, they're gone. And that's a shame. But actually, in many ways, it is a huge shame because you actually had two services that you were offering to these folk. You had serving kitten videos, which is quite resource intensive, and you also had uploading of kitten videos, which is quite resource intensive. And let's imagine that you'd actually had two services running across your, you maybe had a couple of servers. Half your servers were running the web server, half of your servers were running the encoding, the transcoding, the stuff that was handling all of your kitten video upload. Now, the behavior model for people visiting your website is quite different depending on whether they want to view a video or upload a video. So people who come to your site and want to view a video want to see the video immediately. If they can't see the video, they are going to be disappointed and they're going to go away. But people who come to your site and want to upload their kitten video, actually, it would be great if it only took 30 seconds, but if it took 2 hours and they had to go away and make themselves a cup of tea, they would probably, well, by that point, they were pretty committed anyway. It's not as urgent. It's not as time sensitive. They're not as latency sensitive as the people who are wanting to watch the videos. So at the moment, you've got half of your resources dedicated to something you really, really need to always be available, and half your resources on something that actually, if it didn't happen for another hour, wouldn't be the end of the world. So imagine a world in which, when this peak happened in traffic, rather than just go, oh, and it's auto-scaling, now I have to wait 4 minutes for more VMs to come online through AWS or Google if I was being very eco-friendly. While I was waiting for those, rather than just waiting for those new VMs to come online, imagine I thought, well, hang on a minute, I don't really need this half of these servers over here to be running video transcoding. I would just turn that off for an hour and put people a message saying, oh yeah, this is going to take an hour and 20 minutes to upload. It's not the end of the world. So say I turned off all of those applications and I just doubled the number of web servers I had. That might get me over my peak. Or if it didn't get me over my peak, it might buy me enough time for the auto-scaling to kick in, for the additional resources to come online. And actually, it's that kind of thing that Google are doing, that Netflix are doing, that these folk are doing. It's much more intelligent scaling. It's scaling which is not just the one brute force approach of need more machines. It's could we reuse the machines that we have more effectively? And this has never been something that we could do previously, but now tools exist for us to do these kind of things. I'm not saying you should go out and do it immediately, but we've done it on our own systems using Kubernetes and writing our own custom scheduler, and it was quite straightforward to do. But I will tell you more about what we did later. So, but is this crazy talk? Does this really work? Is this possible? If you were cutekittens.com and you were just running a monolith, and you did your video uploading and your video serving through the same application, then this wouldn't work because there'd be nothing for you to turn off to free up resources. So you need, in this model, you need at least 2 microservices. You need something which is latency sensitive, a batch process kind of thing, and you need something which is latency insensitive and something which is that you want to be prioritizing. So you do need some kind of microservices style approach. But that's not crazy talk because we're all talking about microservices style approaches at the moment. So that's not something that is impossible to imagine that we might do. We need a cattle, not pets approach, because if it takes 10 minutes to turn off this, or days to turn off the applications because you've got to go up and someone has to manually turn things on and making sure that things are backed up, then you've got no benefit here. The only reason why this would work would be if you could turn off your latency insensitive applications immediately. So that you could free up the resources effectively in real time. But again, that's not crazy talk, because we're all thinking in terms of cattle not pets, statelessness. That's not something that I can never imagine happening, because we are all already thinking about it. So we're halfway there already, more than halfway there already. The final thing we need is that really you can achieve those container instantiation and close down speeds that we're talking about. We're talking about seconds. Can we really do that on standard hardware using standard orchestrators and standard container engines? If we can't, then this whole thing is just pie in the sky. It's never actually going to happen. But if we could, then that gives us a completely different and much more efficient way to consider scaling in future. Microscaling, as we called it, rather than autoscaling, because we always tend to talk about scaling as autoscaling, but I think we should be thinking about there being two different kinds of scaling. Autoscaling is where you actually expand out the capacity you have, and microscaling is where you just use the capacity that you have slightly more in a more clever way that optimizes for your current needs as opposed to just making it bigger. And it's that is what has completely changed. That completely different change in approach and viewpoints is what really revolutionized resource utilization at places like Google. There's no reason why we can't be thinking that way too. But yeah, when we first started looking into this, we thought, well, we've read the Google papers, it all seems to make sense, but is it really true? Because Google, you don't really know what's going on in their data centers. We think that they're running fancy orchestrators and everything's containerized and it's all really, really amazing. They write books about it, but nobody's seen it because we're not allowed to go and see those kind of things. So, and even if they can do it, doesn't necessarily mean that we could. Maybe they're running specialized hardware, or that they do something so incredibly clever in their orchestrators that none of us could ever reproduce that, could ever get close to that. So we decided to give it a try, because there's only one way to really know how these things work, which is to, there we go. No, that doesn't seem to be working. Right. Oh. Okay, right. Excellent. Right, so this is a custom scheduler we wrote, because the way that you are meant to do these kind of things is, well, one of the interesting things about containers and Docker is that it wraps up your applications, but it also, it provides a very lightweight application isolation environment, which are two amazingly good things. But the final thing it does, which I think is in many ways the best, is it provides a common control interface for applications that are containerized. So you can call an application and start it and stop it using a common API. And all of those, the orchestrators, which sit underneath across your entire data center, on all of the machines in your cluster, all the machines that are part of your data center, and control the applications that are running, the containerized applications that are running on the servers, they rely on those APIs. Those APIs let you do things like, the ones that are most interesting to me, is start and stop the applications. So you've got your containerized applications, you've got your orchestrator, which is maybe it's Kubernetes, maybe it's Mesos, maybe it's ECS, running underneath that. And then all of the orchestrators provide a standard API that you can call to control all of those applications running on those machines. So we wrote, and it's called custom scheduling. So if you want to find out about this, you just need to write a custom scheduler. So we wrote a custom scheduler. This one, I think, is just running directly in Docker, but basically, it behaves much the same way if you're running on any of the, we've tried it with all of the main orchestrators, and it works pretty well. It works pretty much the same way. It's a couple of hundred lines of Go. Doesn't have to be Go, but we chose to write it in Go. A couple of hundred lines, very straightforward code. And what we did was we wrote this custom scheduler, and we said, okay, we're going to fake up some demand, which is the line in red there. It's going to be simulated demand. It's just going to be randomly generated. And we're going to tell you you have 2 container types. And we just produced 2 container types, both of which were busy box. They were just kind of running around, not doing anything, because this was more about the example than what it was actually doing. And we're going to say that one of those containers, the dark blue one, is our high priority container. Maybe it's our web server. One of the containers contains our latency insensitive application, your batch process of some description. And that is the lilac one, the lighter one above. And what we told our custom scheduler to do was that you were winning if you were running enough of the web server style containers to meet the demand, and the rest of the resources on the system were used to run the lilac, the lower priority containers. So you can see that's a win there, win-win, it's all winning. Now it's a lot, but yeah, it's caught up and it's winning again. There we go, it's mostly winning there. Now, we did find that we could only change the demand every couple of seconds if we wanted it to keep up. But that's not bad. That's all right. And this is actually still at the beginning of the use of these tools. This is not crazy talk. This is using standard hardware. So we tried this on our own machines, on Azure and on AWS. And fine, we could run it in all of those places. We tried all of the most common orchestrators. Fine, works with all of the most common orchestrators. We only used the Docker engine. We haven't tried it with anything else like Rocket, but Docker is fine. It's by far the most commonly used one. So this does work. Actually, you could have your applications managing themselves across your data center in real time. And just to prove that this is not just crazy talk, we have a very, very simple production environment called microbadger.com, which serves up labels or lets you know what labels are available on common images on Docker Hub. But we moved that over to do this. We actually connected this custom scheduler up over to our production environment, and we saved 75% on some of our AWS bills. It worked, it was fine. And we used Kubernetes and we used Docker in order to achieve that, and containerized went for a microservices approach to our architecture, and we containerized everything. It's very straightforward to do. You're talking about a couple of hundred lines of Go or whatever language you choose, custom scheduler. You should really be thinking about custom schedulers. They're extremely interesting. Oh, now I've got to stop this. I have stopped that. For some reason, it never lets me do this. I have to go over. No. There we go. Right. So, sorry about that. So what are the weapons that we're using in this battle? What are the weapons that we have at our disposal to get these kind of excellent resource utilization? Well, we've got container engines, we've got containers, we've got Docker. We've got the orchestrators, and we've got custom schedulers that we could write like those. And those are not beyond any of us to do. That was really quite strangely simple code to write. Tactically, we have to, in order to do this kind of thing, we have to go down a microservices route. If we have a monolith, it's just nothing to turn off in order to free up resources. And we have to go down a cattle, not pets approach, because a lot of the benefit of this very fast orchestration is only possible if you can actually turn the application off at the speed that you can turn a container off. Otherwise, you're just going to lose data all over the shop. So, but that's not crazy talk. That's a perfectly reasonable thing to do. And the win is the lower server density, also the increased fault tolerance from using an orchestrator. I would strongly recommend it. It's just basically more than is humanly possible, because we can't do that. We can't be turning things on and off physically because our demand goes up and down. It's just crazy. it is something that should be automated and now can be automated for the first time. This was just not something that was possible for us to do before. Probably actually before this year, I would say that Kubernetes has now hit good enough to go into production for us anyway. And that probably wasn't the case earlier. So basically, we think there's a battle going on, but actually, I thought there was a battle going on, but really the battle has already been won. Containers have been demonstrated to massively, massively reduce resource utilization at places like Google and Netflix. Container engines exist and are reasonably solid. Orchestrators exist and are reasonably solid. We've got everything we need. We just need to start thinking about alternative architectures. We're already doing that anyway, and we need to get everybody used to the idea of running containerized applications in production. It's not perfect yet, but I think in 5-10 years' time, we'll all be doing this. Now, of course, it doesn't mean that VMs have completely lost and we never use VMs anymore. Even Google use VMs. It tends to be a mix. So you'll use VMs for some things and containers for other things. And for hostile multi-tenant environments, containers are still nowhere near good enough. They're nowhere near secure enough. But it is certainly something you should be thinking about, not just for continuous delivery, but also for server density. So yes, containers are coming. So if anybody wants to talk to me, obviously you can ask questions now. I'll also be around for at least the rest of the day. Come up and have a chat to me, talk to me about anything that I've said. And I do quite a lot of work with some guys who are here in Amsterdam called Container Solutions. They're very interested in this kind of thing. If you spot any of them knocking around, they're happy to talk to you about it as well. But anyway, so does anybody have any questions?
Yes, instead of containers, might we also not use smarter package management packagers? So actually run the application inside the same container, so you don't have the overhead of the container solution.
Well, I mean, I would say that there's quite a nice container tool chain now with the orchestrators and the packaging, and everybody quite likes this. So from that perspective, there are other ways that we could do this. But at the moment, in terms of full tool chain, I think that containers are looking quite nice, are looking like probably the easiest way of doing it. I mean, there are other ways you could do it. You could have lighter weight VMs and orchestrate the VMs. But at the moment, containers are a nice compromise of extremely lightweight coupled with a good tool chain. If you really don't want to use containers, there is an orchestrator Nomad from HashiCorp, who do lovely stuff, that will allow you to orchestrate processes, bare processes, without necessarily having any of the application isolation. So there are other ways of doing it.
Yeah, you had a downside for containers, which was networking. Could you elaborate a little bit on that?
Well, yes. I think things have got a lot better there, but fundamentally, the nice thing about containers is you can have millions of them and they start and stop really, really quickly. But unsurprisingly, that got quite far ahead of what networks could actually do. On two sides, really. The underlying network fabric just couldn't really handle it, although there are a couple of good application tools now that have been in production for a while, for a couple of big users, I think. There's Project Calico from a company called Tigera, and there's Weave from a company called Weaveworks, that both are working on making networking fast enough to handle the fact that containers are coming and going like that. So that's got better. There are still issues with things like load balancers not being able to respond quickly enough to new applications appearing and disappearing. So tools still have to catch up with the speed of containers. But these things have a tendency to go together. If we do it, if we demand it, if we use it, then we'll get better tools. But at the same time, so when I talk to people who are kind of ahead of the game on this kind of stuff, they're constantly getting stuck. So they'll do something and then they'll realize that actually the tool they chose isn't really now good enough for the speed that they want to iterate at, and then they'll have to roll back and choose a completely different tool that's ahead on that. So, yeah, it's a very fast-moving industry, and you have to be prepared to abandon things that you've used previously because they won't be good enough for your next use case. So, yes, it's very experimental still, but interesting.
To me, it might become like the biggest blocking issue at this moment would be disk I/O. As you say, like networking, you can probably scale that up one way or another. And industry has been thinking about that. But just conservative disks will probably, if you even add more containers, more transactions and everything, I think the disk I/O might be the blocking issue.
Well, yes, yeah, and actually, I've seen quite a few container experts say that that is the weakest point. And in fact, even if you go to some of the talks from the Kubernetes chaps who are kind of leading the field on orchestration, they do quite often say, start with stateless first. Orchestrate all your stateless stuff, and then worry about stateful down the road. Maybe just even use host. To be honest, I love a hosted database as a service. Let somebody else worry about that kind of thing. Use Aurora or one of the databases as a service from the other providers. Because it's such a pain. I know quite a lot of enterprises who are just moving straight over to database as a service. It's almost their first thing they do after they go into cloud is they go, oh, thank God we don't have to manage these MySQLs anymore and cluster them and make them resilient, all that kind of stuff. Just forget all that and use the service. But yeah, it's a good question. No more questions? So I will harangue you once more. If you take away only one thing from this talk, it's that we can all make a big difference by putting pressure on our cloud hosting providers to use renewable energy. We can make a huge difference there. We need to ask. AWS, Google are already doing a fantastic job here. You can just get it by going straight to Google. Or if you don't want to go to Google, at least say to AWS you considered going to Google because you thought it was important. If we don't tell them that we think it's important, and it really is, then they won't do anything about it. So great to put the solar panel on your roof, but before you put the solar panel on your roof, add effective energy use to the set of requirements on your cloud service provider. Anyway, thank you very much, everybody.